Particular forging process, if we discuss the basic approach of the forging process, then it will be like the one process is basically the drawing out process, and next one is basically the upsetting. So first one is basically the drawing out process, second was the upsetting process. So in a drawing out process, what actually happened, the drawing out, so we can say the length will be the increase, the drawing out process length is increasing, and upsetting process, so we can say the length will be decreased. When the length will be decreased, that means the cross section area is more, and length will be increased, that means the cross sectional area will be the less. So these are the basic approach which we follow. Now if I talk about the classification of the forging process, so in a particular classification of the forging process, we get the smith forging process, drop forging process, machine forging process, and a press forging process. The smith forging process are basically these forging process are basically did by the blacksmith. So the blacksmith are basically use this particular forging process, where they basically use a particular the fuller material, and into that particular fuller material they place that hot and plastically deformed metal, and they basically, so these are both of these are basically actually the fuller, and upon these they basically the hammering will be the perform. All right, the hammering will be the perform. So into that particular the hot and plastically deformed metal, we get the fuller mark. So due to this particular process, what actually happens, the cross sectional area, so metal will be actually the spread, so the cross sectional area will be the decrease, and the length will be the increase. So this is actually happened the blacksmith the smith forging process. In a drop forging process, what actually happened, we have a hot and plastically deformed metal, and upon this particular deformed metal we basically apply the force, repeated force, and because of that particular repeated force, the metal it get its change the dimension. All right, so this is known as a drop forging process. So in a drop forging process, we basically perform like the crankshaft are basically generate the large size of crankshaft. Okay, the locomotive crank, the crank one. So these are basically generated by the help of the drop forging process. And if I talk about the press forging process, in a press forging process, we basically the continuous, we have a particular die, and into that particular die we basically place the hot and plastically deformed metal, then we apply the pressure, and the pressure is basically the gradually increase, and because of that particular pressure, so in a particular press forging process, we have a particular metallic die, and into the metallic die we basically place the hot and plastically deformed metal, and then we by the help of the particular the forging press, we basically the pressing is performed, then the pressure we basically provide, and because of that particular pressure, the hot and plastically deformed metal actually get the shape of the die. All right, and this particular pressure is we gradually increase. So this is, and machining forging, it is a little different from the other forging. We basically talk the machine forging process little later in a detail. So one example I basically give, by the help of the machine forging process we get like the nut, the screw are basically generated. All right, so this is basically the machine forging process. And in a particular forging process or the press forging process, mainly we provide few allowances. So this is basically, first allowance is basically known as a like, so first allowance is definitely the it is basically the shrinkage allowances. Then we provide the die allowances. So the die allowances and the machining allowances. So shrinkage allowance, the metal in the high in temperature, and because of that high temperature, after the metal are basically solidified a particular stage. So first the liquid to semi-solid, the semi-solid. All right, this is SS, I denoted by the SS. Liquid to the semi-solid, then semi-solid to the solid, then the solid to the room temperature or room temperature. It is not a recrystal, room temperature. All right, room temperature. So this is how every metal should be solidified. But so that particular solidification time, if there have a possibility the metal will be get shrinked. So for that particular aspect, we basically provide few extra material into that particular metal, so that it basically taken care of the shrinkage cavity. The die cavity, if I talk about the die, the metal, the die itself withstand the high temperature of the molten metal, simultaneously the pressure of that particular forging press. So for that particular reason, the we basically provide a die wear allowances over there, and a machining allowance, the surface finish purpose, we provide few extra material over there. So when we provide the extra material, so during machining we basically remove the extra material. So this is basically the machining allowances. So this is all about the forging process. So next video we discuss on the extrusion process and the drawing process. So thank you.